Professor Roy, have you joined? Professor Sarkar?
Please wait for a few minutes.
Am I audible, Professor Sarkar? Professor Sarkar, am I audible?
Yes, sir. Yes, sir.
Okay. Has Professor Roy joined?
Sorry, sir.
I'm asking whether Professor Roy has joined, Professor P.K. Roy.
No, sir. No, sir.
By the way, please check if Riti Chatterjee madam has joined or not. Just can we check? Is Riti Chatterjee madam?
Yes, sir. Ma'am is already joined. Yes, ma'am. Yes, sir.
Okay, okay. Welcome, madam.
Yes, I don't know, I'm muted.
Are you? Professor Sarkar, please check. Or you're muted,
Yes, sir.
but I could hear you. Oh, I do. Finally, yeah.
Yes.
So no.
Sir, along with you, Mrs. Riti Chatterjee is there?
She has joined.
I am there.
Madam has joined. Madam has
she
joined.
Oh,
Ah.
madam has joined.
Madam has joined.
Okay.
No.
Should we start the session, sir? Or some
what is the
people are
time?
joining because, yeah,
Acha,
34 participants, including.
Madam, am I audible?
You are audible, but am I audible?
Yes, you are. You are.
Okay, fine.
You
fine.
are.
I can hear you very
Fine.
clearly. Yes.
Okay, fine. Good. Now, I believe, should I just check in the meantime, just for a moment? Is Professor Sarkar, are you there?
Yes, sir. Yes,
Professor,
sir.
I'm just trying to. Acha, then I will do that. Okay, fine. I mean, in case, but my presentation is with you also, right?
Yes, sir.
Hello.
Sir, one thing
My
I ask, sir.
presentation.
Yes, sir.
Okay. By chance, if
Yes,
there
sir,
is a
yes, sir.
network issue, then you have to play from your end. Okay. Because there has been some network issue. That's why I didn't want to take chance. So I shared my PPT with you.
Sorry, sir. Can you repeat, please?
No. I said that there was some network issue, so I shared my PPT with you. In case there is any problem, if I find it is this sharing is a problem, then I will ask you to play from your end. That's what I said.
Okay. No. Okay, yes.
So, should I start, sir?
Hello, sir. Nam, sir.
Yes.
I have one question to ask, sir. Will you start first, or should ma'am begin?
No, first it will be my session. I will start, and then
Okay.
Madam will take over from there. My
Okay,
session will be
then I
shorter
am
because
making.
I have already spoken in several sessions uh, in some parts. So what I will do is I will do a short preamble. Then Madam will take over. Um, she will be presenting several case studies and all. So she will need more time. And since I have already spoken in 2-3 sessions and discussions, etc., so it is better that I keep my presentation this time short.
Okay.
So
That's
I'm
what
starting.
we have discussed between ourselves, myself and Ms. Chatterjee. Is that okay with you? That's what we planned.
Yeah, I'm fine. Means I can take for around an hour, definitely.
Absolutely not a problem. So I will try to keep it within half an hour. So she get the requisite time.
So what
Absolutely.
will be the mode of interaction? Just wanted to know. Means if someone wants to speak, they will be speaking at the last. The question answer session we will do at the last. Just wanted to just check it out.
Actually, it depends on you, the faculty. But if you ask them to ask questions in between, they can, or they can ask at the end as you prefer. So there is no fixed norm. It depends entirely on the faculty how you choose.
Okay, I would
And
like mode. That is better for me always, so that I can feel. Okay.
okay, so I mean, people are also writing in chat box, and people are also asking questions. So sometimes I don't know, and so whichever way,
So
it
I
is
would,
your session.
yeah, I would prefer if they can ask questions, and we are very focused that way. I'm not looking at multiple channels, but I'm just focusing on listening to whatever questions are there.
Hmm. Yeah, no. Please don't look at the multiple channels. If there is anything in the chat box, someone will definitely read that out for you.
Okay, fine, sure.
Professor Roy, I think we can start, right?
Yes, sir. Yes, sir. So I am
Okay,
formally
okay,
starting the
fine.
session. So,
Yeah,
dear
yeah, yeah.
participants, this is the last session. After that, the session will be up to 6:30. After
The
that,
last
test
lecture session. After that, there
last
will be two sessions.
last
Yeah.
lecture session. Yeah, last lecture session. So after that, online test and feedback will be there. It will be from 6:30 to 7:30. So in this session, in this lecture session, our speaker is Dr. Pranab Kumar Dan, our own professor of School of Engineering, as well as coordinator of the program, ATAL Faculty Development Program, as well as the Pro Vice Chancellor, Seacom University, and Mrs. Riti Chatterjee, Managing Director, Plumbull Research
It is
LLP.
Plymouth.
Yeah,
It is
Plymouth.
Plymouth.
Yeah.
Plymouth.
Okay. Sorry. Yeah.
Mhm.
So before that, let me introduce some bio profile of Dr. Pranab Kumar Dan. He's a professor in the Department of Mechanics, already told. Now, before that, he was at Indian Institute of Technology, Kharagpur, and obtained his bachelor's and master degree in mechanical engineering from IIEST, Shibpur, which was previously BE College, and PhD in production engineering from Jadavpur University. He has been the founding head of the Industry Engineering Management Department at the West Bengal University of Technology. Before joining academics, he worked in several renowned national and multinational industrial organization and senior position. His teaching and research interest encompass product design, design process, technology, entrepreneurship, innovation, and design thinking. Frugal innovation and eco design. He has published more than 100 research journal in reputed journal and conferences and book chapter, and he has supervised several PhDs guiding others. He is also advisor mentor of startup companies, and he was the chairman of the entrepreneurship cell at IIT Kharagpur for a decade. Dr. Dan was the principal and co-principal investigator of several sponsored projects, including the prestigious National Initiative for Design Innovation sponsored by MHRD, Government of India. He has traveled across the country and abroad to deliver talks, presentation on subject matter. Dr. Dan consulted a number of companies and conducted training program. He is a fellow of the Institute of Engineers in India. Dr. Dan has been on the technical program of committees of renowned national and international conferences like ICORD, AIMTDR, ICITM, IDEAS, and chair technical sessions while others. He served as the PG Curriculum Review Committee member at IIT Kharagpur and launched an NPTEL course on product engineering and design, thinking to build competency innovation in innovation domain. He is the member for capacity building for the program launched by Ministry of Education, Government of India, and as invited expert for a couple of National Institute of Technology. Dr. Dan has been associated with CII for past 2 decades and with VDMA as a jury member for its Manufacturing Excellence Award. Besides ICC and MCCI, he was officially Innovation Ambassador from IIT Kharagpur. So this is a bio profile of Professor Dan, Professor Pranav Kumar Dan.
Thank you, Professor Roy, for your kind introduction. Now, what I'll do is since the time is short, I would quickly go through the slides. I'm trying to share now first. Can you see?
Yes, sir. Yes, sir.
Is it visible?
Yes, sir. It is.
Okay. Fine. Thank you. So what I'll do is I will quickly move to from one slide to the other because I have to uh, uh, meet a target that by 5:30 I should be able to hand over it to Ms. Chatterjee so that and if there is a time left by any chance, then we together will discuss and close the session. However, I don't feel that will happen because she will present few cases. Be that as it may, so we'll take care of the thing. Now, that is why I have kept certain pictures because that would be almost self-explaining. But I quickly will pass through some. Um, a preamble, you don't need really to read through the text part. Basically, it is to be understood that when we are talking about Industry 5.0, in fact, Industry 4.0 has not yet matured in various parts of the world, more so in our country. But then, therefore, why are we discussing Industry 5.0? For two reasons. One is when there is a technology, new technology, we cannot be completely oblivious to that. That's number one. Number two, today's preparation would help tomorrow's professional. So, and more importantly, if we have some idea about Industry 4.0, 5.0, so then we know where actually the 4.0 ends or where the handholding actually is required, and therefore those who are planning for Industry 4.0 would actually be targeting that handholding in a seamless manner. That is the intention. So as you can see that it is on the foundation of Industry 4.0, of course, where from we expect the resilience, But one thing that industry 4.0, which is also called light out factories, that means the production can be done when the lights are off. I mean, when the as if the human beings are not present. But here, what is failed to us, that if we involve the humans in the loop, then its efficacy is increases in a variety of ways. One of them is that it can have certain intuitive and creative aspect which got which possibly would be missed out if we exclude them entirely, as we practically try to do it industry 4.0. So the human centricity is important, and that will actually give sustainability, since human involvement would enhance the opportunity to contribute the creative contributions. Say for example, design of a system, kind of a situation where a person who is in the thick of things would help. Basically, as we know that in industry 4.2, we are talking about the technologies like say IoT, like say AI, or like say um, digital twins, like say CPS and all that. On top of that, what it requires is the human creativity extraction. So obviously the next question comes that, okay, we will deal definitely with that, but then what are the cornerstones? See, in the cornerstones, possibly you can see this slide here. I would play better in the slide show mode, the current slide. Is it better now? Looks like it is better. So Professor Rai, is it better? Can you see this?
It's better.
Achha.
Yes, sir. Yes, sir.
Okay, fine. So so here, just a minute, let me hide it. So human centricity, that is collaboration between humans and intelligent machines, like cobots. Cobots are actually collaborative robots, where in the traditional types of robots or adaptive robot, they function, but they are not so I would say safe to work alongside human beings, where there is a chance of hitting or injury, which are taken care of in this human consideration, ergonomic consideration. So cobot is a solution that is now being considered for that industry 5.0. Sustainability, obviously, that the greening is the important thing now. And two things, obviously, when we are talking about greening basically means that emission of greenhouse gases should be reduced. But how those will be achieved, those are the questions. So one answer is the renewable energy, no doubt. But another thing which is becoming very popular these days is the circular economy. Circular economy, basically, at the heart of the circular economy lies circular design. That means we need to design our products in such a way, maybe a car in such a way, that once the its pre-specified life um, uh, ends, it can be recycled in the system to re-energize or rejuvenate or refurbish for further use. For example, I don't have time to go into all the details, but then one thing, just for indication, I can tell you that in one of our research, what we proposed and did was that at the in the end of life cars, the conventional fuel cars, that is IC engine based cars, about 80% of the parts, including the chassis, the body, and all those remain, particularly the static components, remains largely unaffected, but the rotational parts, etc., wear out a lot. Uh, so, but they at the end of life cars are expected to be scrapped or supposed to be scrapped as per the rule. Of course, they are getting some extension with the fitness certificate and all, but then that is what it is. So, what we did a research that how to optimize that if a end of life car, the IC based car, can be reconfigured as a hybrid electric vehicle. That means the energy greenhouse gas generating engine would be removed, and instead a small engine will be put alongside a battery. The battery will be electric, and therefore it is electric driven car jointly with a IC engine facility. Resilience is to come through the the adaptability through the industry 4.0, and the that would be able to obviate many disruptions. But most importantly, the last one also goes back to the human aspect very much, that customization. In fact, personalization or customization, which basically means mass customization. Mass customization is what? What is mass production? We know customization. No, what is mass customization? Because see, the question is that normally when we are in the production situation system, then if we are trying to produce several varieties, the productive time is eaten up by the changeovers. Now, if we can do something by which the changeover can be minimized or even or nearly eliminated, then there is practically no difference between one-off production and continuous production or mass production. Then this actually can give different varieties. Say I'm giving a simple example. Suppose in a car manufacturing company, I'm not going into the other nitty-gritty details for simplicity of understanding. If I just say that, okay, some cars will have music system, some cars will not have music system. If we just take these two variety, then obviously we can create a situation where the music system is a customized requirement demand, and that can be put in a in those cars which will be needing those, and where the customer are looking for those. But then that will not hamper the volume production to support the economy of scale. Resource constraints and complexity and metrics are the challenges in this whole thing. Already people have talked about first, second, third, fourth, this thing, and we are just on the fifth. So in the fifth, you can see the mass customization and cyber physical cognitive systems. That cognitive aspect is coming in, where the intellect and human creativity are being considered, and where the sustainability comes through the human-centric interventions. I quickly will pass through because these are practically were discussed in different ways in different sessions. But here that I just mentioned that by transitioning from industry 4.0 to industry 5.0, one creates higher value jobs before as the than before, as the freedom for design responsibility gets back, which I said the design creativity, design responsibility comes back to the human beings. Just a little while ago I was talking about that. But that the with the human inclusion, the I would say the environment or the okay, space requirement, whatever you call it, the system gets a bit bigger. But in other words, to tackle the situation with a human presence in the entire system, it makes things safer overall. Well, so the freedom of design to work is that creativity aspect, and then this collaboration is the key. now what is the status of industry 5.2? People are talking about 4.0 largely, and that too has not yet been fully implemented or extensively implemented. But then there are some regions, some geographies who are actually making good strides in this. For example, Germany, Japan, and Denmark, they are leading this industry 5.0. They are doing some real good work. And well, India is trying to adopt, and some large companies are actually grappling with it. But soon, I believe that when one would be more accustomed with the industry 4.0, will be able to move on to the next stage, that is I 5.0. And so this is what the Indian situation is, and that will be that is supported by initiatives like Make in India and production linked incentive schemes, which is a very good scheme. Production linked incentive scheme is this, that if companies, even the foreign companies who are actually selling products in the country, government of India has created a scheme that if they bring in the Indian component or Indian raw materials, etc., then they would get on the sales value certain incentives, which actually will support Make in India. In fact, I would like to call it Make in India. In fact, I would consider it just not manufacturing, but the high value added aspect, the design, I would not like to part with. So the wider implementation will depend on policy alignment, digital infrastructure, and collaborative efforts. Well, because I would not take much time as I promised, so I would just give two examples. Say how Industry 5.2 and smart cities and Industry 5.0 and healthcare. So you can understand that in a smart city, there's too many applications. They are, say, from security surveillance to traffic priority to solar energy to water management to smart offices, smart grid, clean energy, utility management, so on and so forth. Endless things, or they should be connected to each other, and that is where this Industry 5.0, in which is human centric solution, the societal, that is the, sometimes it's called society 5.2 or all that, so that is now coming in. But as I said, these are all very early stage situations, so I am not saying that this has been implemented in a widespread or in a very many companies. But today the discussion is focused on 4.0, but we have decided, in fact, I have spoken with Madam Riti Chatterjee. She also will be focusing, as I understand, largely on Industry 4.0, but then would add that how it can move on to Industry 5.0. That is the understanding between me and her. We had an initial discussion on this. And again, now this healthcare aspect also, here the personalized medicine, predictive health, personalized medicine. So depending on the personal conditions, criteria, etc., how those will be added, how much would be, say, we know, say for example, just a simple thing many would know, the thyroid medicine will be mentioned based on the body weight. So those are personalized kind of a consideration. So now when it will be digitalized, it will give some automatic thing instead of depending on very, I would say, vague judgment at times. So focusing on sustainable and proactive well-being rather than just treating illness. Key areas include AI-driven diagnostics, robotic assistance. In fact, I will come back to the robotic assistance. One is the robotic assisted surgery. That is the surgical tool goes into the body. But I will just show one that we have studied, and we have done some research. I will come to that in the next slide. I will talk then. And also see wearable tech for the wearable watches and other things, wearable tech for continuous monitoring, all aiming for tailored treatments, better outcomes and efficient tailored treatment, the very individualistic treatment. Like say prosthetics, as you know, everybody's knee or joints, etc., are different. So the measurement is to be taken. So even for the, I don't know if anybody has replaced the tooth or teeth, they know that there is nowadays, they first will find out using the digital system what is the cavity, and accordingly it will be constructed, and it will be put back in the mouth. So those are individualistic thing. This is I was talking about the what academia is doing about it. And the right side there is a robot which is actually the surgical assistant. That's the name of the article that we have developed jointly with my colleagues. In fact, they are the first authors. I am the last author there, so I would give credit to them. But since it is the need that I am presenting it here, so because I am not taking individual names, that is perhaps not the right forum. The designing a voice controlled AI based cobot arm for surgical assistance, and drone, which is the unmanned aerial vehicle UAV. The work on feature prioritization of drones from the perspective of designers and manufacturers. Both will be presented in the forthcoming Indian Engineering Congress next week. It is on from 19th, I believe. So some of this work is this. So I will not take much time, as I promised. So if there is any question, I would be pleased to answer. Thank you. Professor Roy? Hello? Am I audible?
Yes, sir.
Yes, sir. Yes, sir. You're
Okay. Now, how do I? Okay, fine. So, I want to pull down my sharing, or it is not required. You can manage otherwise also.
We can, sir.
okay, sir.
Okay. So I am putting stop sharing, right? I'm putting stop sharing. Stop sharing. That's what I did. Okay, fine, done. Okay. So now I believe I'm on time. So
Yeah.
if necessary, then
Sure.
we jointly will come back at the end. Yeah.
You've done a great job, and beautiful, in a very short and sweet manner, you covered all the aspects. That was amazing.
I only tried, madam, to make a foreground or a foundation, because he will be talking about various case studies, and I believe this will help to some extent. So I tried that.
It was
Thank you very much.
spot on. I think we just, without discussing, we have just, kind of matched each other probably. Let's see. Let's go.
Yeah.
So I'll be speaking on definitely some of your points. Okay. So I'll share the presentation. Is it visible?
It is not.
Okay. 1 second. Share. Oh, no, I got it. Okay. Hold on 1 second.
Yes, sir. It is visible.
Yeah, it is visible.
I will go to the presentation mode. Okay. So as Professor just told, right, it is human innovation, creativity that needs to go beyond just technology, right? So Industry 4.0 had been very focused on technology, right? Autonomous, bringing in autonomous after automation. If you look at, mass production, and first automating, and then simple automation, and then basically mass production, and then a little bit sophisticated instrumented automation, and then going into autonomous was the industry 4.0, right? Decisions are taken by the machines, by their understanding from the ecosystem, right? So industry 4.0, and when we come to industry 5.0, how does it work together with the humanity? How does it help us in the sustainability of the environment? How do we still be resilient to any kind of disruptions that can come, right? And how do we economically continue, financial part, right? So these are the major things that has led to industry 5.0. So so a little bit about me. I graduated in 1986 from RE College, Durgapur, and
I believe your CV will be read by Professor Roy. Professor Roy, I mean, I believe your introduction is due for Ms. Chatterjee. Professor Roy?
It's okay, Miss. Basically, it'll
just
be
1 minute. Just 1 minute.
Yes,
We are following a pattern.
sure.
Professor Roy, am I audible?
Yes, sir. Yes, sir.
Please introduce her first. I mean, instead of self-introduction, it is that we are doing it from our side, our end. So please.
Sir, actually,
Slide you want to introduce in here?
yes.
Should I put off the slide or should it be there?
Yeah, actually, somehow your CV or is missing from our.
Okay. Then she will, madam. We are.
Yeah. Anyhow,
sorry.
Sorry for this one. Anyhow, somehow it is missing.
Okay,
from our,
serendipity that madam started already introducing herself.
okay.
Okay. So basically, I then joined job in NTPC, was there for quite some time in corporate design, and then for a short time in MN Dastur, but most of my my job has been in the IT industries. I mean, I started with Tata Consultancy, then in Cognizant, then IBM, then Reliance Communications, back to Cognizant. And then, I started my startup. So in the last
I believe that she was at very senior level. This is to be understood, and currently she is the managing director.
So I don't know. Anyway, so basically, my last few years has been in driving very large, complex system integration projects, and these were 100 million plus, which were kind of very difficult to really conceive and execute. They were challenging projects, and it's there that I saw that the new students and the freshers that were coming into the organization needed to have more industry acumen, and that is the genesis of Plumule. Okay, so Plumule research started with the concept of growing the capabilities to visualize the industrial opportunities and be able to understand how the business runs, how manufacturing runs, and be able to devise solutions, design solutions, and from ground up. So that was a very key part, and we call our vision is, let me go to the next slide. Our vision is give every student a dream. And give every student a dream, meaning that we have a lot of technical expertise, and the world also had been focusing on a lot of technical expertise. But with that, we have come to a stage where we can be really, very imaginative about the things that are possible today, right? So almost we are reaching infinite innovation. There are so many things that we could never dream of earlier. We can think of now. So Professor talked about this mass consumerization. Let's say mass consumerization of medicines, right? And the medical gadgets. It's designed just for me, which is the ideal situation that we'd like to have, right? So capability to do that, right? So those are the things, that is where we are going, and that was the thought process why Plumule was created. Plumule means the shoot, the new shoot. Means in Bengali we call it Onkur. Also in Hindi we call it Onkur. And research means the research here means to create research mindsets in the young minds so that going forward we can innovate and imaginatively and grow a new paradigm of manufacturing systems. So that's what we are a DPIIT recognized MSME startup, and we started, our starting point was with experiential education, the Coles model, in which there is an active learning through doing. And it's a cycle by which there is a reflection and there is a implementation of the learning in the next cycle. So this is what we have been experimenting. Now, let me just explain a little bit of since it's a faculty development, so maybe this will help everyone. So let me just explain how such a education program happens. So we get problems from the industry domain. We start with the thought process. The team starts self-organizing around the problem, and it goes through a question answer kind of model in which gradually the exploration into the problem is done. If you look at the framework, the closest framework to it is the jobs to be done framework. Okay, so that's what we adopt, and the process is called industrial design thinking. Any question, anyone? Anyone had a question? Someone was speaking. Okay, so we have delivered quite a few projects with this mindsets with the students also helping in projects going live, and these applications are running live for past 1 year. Like the continuous ambient air quality, and we'll go through them. I'm not talking a lot here, but they're on the screen. So going to the next slide, yes, these are some of the client testimonials, the completion certificates that we have from Rail and from DSP. We also did for Matix. So we are currently working for RINL, and we did also projects for another company called Project Concern International. So we'll just go through them gradually. But first, so I recently went to Vizag, and there I chanced upon a very good, magazine that is published by IIT Madras. You may like to, kind of look at it sometimes. It's called Shastra. And one of the issues that is December 2024, January 2025, right? They were discussing about the cities and the smart cities, right? And I thought, oh, what a timing. And I actually, kind of cut and paste some of the quotes that are there, right? So I'll just read them out a little bit. Cities will determine the Earth's future. Therefore, humans need to create the right kind of cities. And the whole paper actually discusses about it, but some points from there are, the ideal city of the future will have plenty of vegetation and adequate public transport and be resilient to droughts and floods. So as you know, the urban sprawl, right, how the cities have grown is how people have migrated from rural areas, and where they found comfortable place to an economical place to actually set up their homes, and also commute to their offices, right? That is how the cities have grown. And you can see a lot of the city has grown around the car parking spaces, right? Then as part of the city have grown, where you have good schools, right? So it is not in a very planned manner that the urbanization has happened, right? But when we look at growing smart cities, we are looking at technologically advancing to a mechanism where the state becomes very comfortable from all aspects, from healthcare point of view, from commuting point of view, and from energy consumption or energy rather now we should say energy generation, right, with the renewable energies coming in. So from all those aspects, how to build a city with maximizing the automation or autonomous operations and making it easy for life, right? So now the new urban design philosophies look at, how to work out the transportation systems, how to design the automation in terms of, so that people know when the buses are coming, people know, then there is a mechanism to help all the old people to board onto the buses. So a lot of new things are coming in. Then there are also areas where we are looking at availability of the healthcare facilities. So ambulances, how they can be informed and prepared with all the gadgets that are required to bring the patient from home, and it becomes very easy to communicate. You don't have to go and book and wait and all those things. It becomes almost they're ready almost all the time, right? So advanced preemptive working of the whole ecosystem, urban ecosystem is coming, right? Then the other thing is that, Professor talked about the healthcare, right? So there, how the materials are changing, so that they can, new materials, new clothing materials, right? They have sensors embedded in them today, right? So with the textiles, electronics is getting embedded into the textiles, and they are still washable, right? So this is a new material design there itself, right? And of course, we are looking at the smart energy solutions, how we can generate energy that is less carbon content, and using solar or any other form, and that ultimately also be able to give back to the grid. Such concepts were never there earlier, but these are the things that we are talking of today. So this is, considering this is happening, the single most important factor in all of this to happen successfully is that we put the usage, the interfaces, the connections, that is the humanity at the center and not technology at the center. Putting technology in the center so far has got us here. But what has got us here will not be what will take us through the next steps. There, it's the human beings, it's the interface with the automation, it's the ability to sustain our Earth through the climate changes. These all will matter a lot more to be able to deploy technology. So technology is supportive, humanity is central. We invest more into it. And that's why this topic is there today of Industry 5.0. So I will do a little bit of backup. When manufacturing systems so far has been mostly hierarchical, we call it vertically integrated systems. You have the product and you have field devices or sensors mounted on it while the product is getting assembled. There are sensors to sense, there are controllers to control how the assembly is happening. A group of manufacturing control and sensing and control systems come under a workstation. And these workstations collaborate between themselves in the work centers, and they finally roll up to the enterprise. It's very, very limited to the enterprise and hierarchical. This is very simple to manage, right? Now let's look at it with the Industry 4.0. Where are we going? We are introducing capability to communicate between organizations at the manufacturing level. So The systems have to become very flexible and very knowledgeable about what's happening elsewhere in the supply chain. While the other one was vertically integrated, this is vertically integrated as well as horizontally integrated, supply chain integrated. And all the participants need to be able to communicate with each other, understand each other, and drive its decisions from this communication. Okay, so it has become a network. The products have become a network. Now I will come to, how this conception of Industry 4.0 in manufacturing started. It started in Germany, right? It started as Platform Industry 4.0, where if you look at it, this dimension, we saw it in ISA 95, right? Product, field device, control device, this kind of hierarchy we saw. This dimension was also coming into place through the ERP systems, right? ERP systems, MRP systems, you have function-wise also integration. But this dimension, the life cycle value stream, that is the result of RAMI 4.0. So anyone can help me understand, any one of you, what could be this life cycle? Anyone? What is life cycle? Okay, I'll come to it. So life cycle is the life of any product right from its conception. That means from the raw materials to the intermediate finished products to the products. Hello? Hello? Okay. Someone wanted to speak something, but we'll talk then at the last. So basically, when we talk about life cycle means the manufacture from the raw materials where it is sourced from, the manufacturing. So then the design of the product, then the manufacturing of the product, and then where it is distributed, and finally at the retail point, then to the users or the consumers who are using the product. How do we connect all these dots and the information can flow seamlessly so that the product becomes more and more capable of innovation for further usage and sustainability? This life cycle concept has come from the basic concepts of sustainability, the challenges that we are going through today, the resource wastage that's happening, the resource shortage that's going to happen, the global warming that's happening, the lack of, the problem with education, the problem with knowledge sharing, the problem with data sharing, those are the key areas that are happening. And to address that in the architecture of manufacturing itself, we have introduced the life cycle value stream. I will quickly cover a few paradigms that are shaping up. I think it's important for us to understand. So basically, Professor had already told us about the what part of it. I'm trying to go through the why and the how part of it. So this is an example study we did on Nissan, with Nissan actually, and of data sharing. Okay, the concept of data spaces. So in a moment it will be clear. So Nissan's journey to sustainability and innovation, in which everybody, like everybody, they're also looking at this carbon dioxide reduction, and how do you ensure a steady supply of the raw materials, and then how do we ensure that all the raw materials, energy, minerals, materials, water, air, everything is there in a sustainable manner and they are able to continue. Okay, so we know the water shortage and all the problems that are happening, right? And of course, the carbon footprint and all. And they decided that, they need to work in collaboration and continuously evaluate what is the global impact of their manufacturing so that they can stay in the game. That's how they were looking at it. So this led them to think in the way of how do I understand and how do I preempt what's coming. And for that, they found that in their chain, they had to look at the different data. So let me just introduce this collection frameworks and the considerations that needs to be there. Okay, so today the data is very local. The production data, the manufacturing data is very local to every organization that owns it. Tomorrow, we are looking at making this flexible to be able to share across. The other important part is that when the data is local, the corrections are also local. And the thing is that some data can remain not corrected. But when you are looking at sharing, that means you're creating a bigger impact. A small mistake in the data now becomes multiplied across the ecosystem. So consistency in data collection is becoming very, very important for the sustainability of the manufacturing production. Today's manufacturing is global. Materials come from different places. They are partly assembled in different places, and they are finally assembled in different places across the world to be able to deliver to the distribution network that is needed to reach the final users. So new models of delivering close to the customer, assembling close to the customer have come up over the past few years with the globalization of the production, right? So that means the data that are important, that relate to each other, are globally spread. Okay, so globally spread means what comes in is the GDPR, right? What comes in is the data protection, the ensuring that the data can cross the boundaries of a nation, right? Then, so basically, this will require formulation of policies on what data can be shared and what data cannot be. Okay. Then the other thing is that different people define data differently. The vocabulary is different. So how do you share the vocabulary across the different companies, across the different institutes or units that are actually participating in this manufacturing process? And last but not least is the quality and the traceability of the data. From where has the data originated? If it has gone through transformations, then understanding those transformations before you actually use them, right? So today's world of, which is where we are promoting zero trust systems, it's very important that we are able to understand every data that we take or that we give in the terms of its source to sink, how it was created, how it was used, and how it is getting deleted. This brings us to the concept of, the data mesh or the data exchanges, the concepts of data spaces. So if I look at it from the way Nissan had treated it, Nissan was looking at the beyond them, the customer, the connected customer, and the system integrators that are there, I mean the distribution network, right? They together, because they own the customer, they together formed their own network, own data space. right? There they had complete control over the data. They knew exactly what's happening, exactly which car is going to which customer. That was existing, and that way they knew that part. What they didn't know is that which supplier product or supplier material is going into which car, and how are those materials being produced, under which conditions, right? So that for that traceability, they actually looked at this kind of architecture. Okay. So tier 1 suppliers, tier 2 and 3 suppliers, okay, so they will form different kind of data spaces. Each data space has its own set of data products and domain owners. And the network of all the data spaces is called the data mesh. This is how the data itself is getting organized. So why am I focusing so much on data? When I talk about flexibility, the only rigid thing that we cannot change is data. Processes we can tweak as we want, but data we cannot. So we have to organize everything around the data. That becomes very, very central. Okay. The other thing is that, so one is that creating that availability of the data so that there is transparency in what is happening, there is transparency, there is traceability, that all that is important. But when all this becomes important, the need for federated governance, what is federated governance? The governance that is working across all the nations. The policies that will create a collaborative group and ensure or enhance data sharing wherever it is required. Those are the policies. There are security controls, definitely, but then there is certain amount of sharing or federation of data that is needed to be able to understand or preempt or actually do any kind of autonomous manufacturing. How will you do autonomous manufacturing if you don't know? Let's say let's say I want to make pig iron that is only having between 0.3 to 0.5 silicon content. Very simple problem, but can I do it? If I do not know what my raw material contains, if I do not know in what process this raw material got converted into sinters or pellets, if I do not know how in the blast furnace, specific blast furnace behaved, I cannot, right? So it is very important to share data across the silos of manufacturing. Okay, so that gets us into the federated A, and there are a lot of other concepts that are coming up, but this is in a nutshell to keep you posted. Now let's say, let's go back again to look at, how Nissan would have operated. So Nissan being a manufacturer, so it has to get the data from its suppliers, right? And it has to share the data. And also it has to get data from them, the repair shops. The parts supplier should provide the data, the repair shops. When the car comes to the repair shop, they have to also exchange the data with manufacturers, right? And of course, the customers keep complaining. That data comes to mostly to the dealers, and through the dealers, it should come to the manufacturers. Now, we need to have platforms by which they are seamlessly and almost on real time shared, so that there is complete transparency on making or manufacturing a system, right? Whenever we talk autonomous actually is very, very deep. Autonomous requires connected data sets. Otherwise, going autonomous is not possible, right? Then when you look at a car, right? Car is not just the body or the seats and all those things. Car has a lot of instrumentation, and all this instrument data are going to the instrument provider, instrument manufacturer. Now, those measuring data spaces have also to be shared. So I just am giving you a few data spaces that have become important in the ecosystem of auto manufacturing. Okay, so the IT service provider, they also do a lot of things on the car maintenance. They preserve the maintenance records, or they check, what kind of request the customer has given, what kind of processes have happened, where the material was sourced from in the ERP systems of the manufacturer, right? So these are all very, very important to get connected, to be able to do the newer systems that we are looking at. I mean, the industry 4.0 systems that we are looking at, right? And from where once this gets connected, at any point of time, we will understand how many more hours under certain operation, under the average operation, the car can give. And we know how best to utilize it, right? So this is what is the life cycle dimension of the platform industry 4.0. I come a little bit more visual here, how the futuristic systems will look at, right? At the center is the manufacturer, and then on the left side, we have the suppliers, the tier 1, tier 2, tier 3 suppliers, and then on the front side, we have the forward side. On the right side, we have the distributors and the customers. Now, if you look at it, this circles, right? These circles represent the data of this node. Each circle, dotted circle, represents the data of the node. If I allow the data to propagate much, it will get distorted. In the process of ETL or whatever, transfer of data from one system to another, it will get distorted. So how do we enable such a system? We localize the inferences and share the inferences. That is what the policy will say. You do not have to share detailed operational data. It is not possible, but you can share the inferences that you had from the operations, the intelligence that you got from the operations, and that can be shared. And if that is shared, then you can get the causalytics moving from manufacturers down to tier 1 to tier 2, tier 3 to be able to come up to the root cause. And all this needs to be done on a trusted plane. Blockchain is a very good use case of it. Okay. So quality of the data is best at its source. Inferences are shared, and causal AI actually moves from one step to another to go to the root cause. That helps in quick correction and then also forward. Correction, this is prevention, this is correction. These are examples of this, integrated Katina, Gaia. These are all different examples of how it is shaping up the data space. I think around 2035 onwards, we will be able to see some things that will come into place. This is what we had suggested. We had suggested as a roadmap. So we told that we need to put the humanity at the goal, okay, and not automation. First, the traceability, carbon dioxide, food, all that affects the usage and the sustainability that comes, and then look at who are the participants to this. Nissan alone cannot do it. Who are the participants? And then build the trusted chains. Again, when we actually look at implementation, we look at first the data, then the orchestration. Okay. Going forward, I will discuss a few of the case studies that we have done. I just need to have a check on time. I hope we have time, some time now. We just need to. Okay, not much time after. Okay, So when we delivered, when we built these systems, this is a continuous air quality monitoring system, right? So we built this for railways, and it does multiple gases sensing, and it sends it over the cloud from where. So because this is a box, very quickly we delivered. We had to do this very fast and very economically. We created it, and then we transferred the data was being shown on a TV here. Okay, mounted here. We were also asked to do a, kind of convert this to a PCB. The problem with PCB and the concept of PCB, right? Problem with PCB is that once you have fixed it up all and you see that things are not working, you cannot deliver fast. It will go through its cycle of maturity and you cannot deliver fast. So agile, we need to look at something that is programmable PCB. Okay. 3D printed PCBs are also being talked about, but programmable PCB where we are not looking at mass manufacturing, but being able to learn from the fields and be flexible and be customized. So that's the learning we had here from a manufacturing point of view. Let's go here. Now, this particular project was for Durgapur Steel Plant, and they have this sinter plant where iron ore, coke, and limestone, everything gets mixed, and they form the sinters. We call it in our olden days, we used to call oven, right? The unun and the gul, right? Most of you are Bengali, so you'll understand. So sinter is something like that. That is fed as a base material in the blast furnace, and it is reduced, right? Now, this during the manufacturing of this sinter, it happens at around 900 degrees centigrade to 1200 degrees centigrade in the sinter plant. But once these big masses are produced, they are hammered, they are very hot, and they are cooled in a cooler. Now, if the sinter is not proper, what happens in the cooler is secondary ignition happens, especially in the circular coolers where it is kind of a closed environment where secondary ignition can happen. That is, again, instead of getting cold, the sinters start burning again because of non-homogeneous mixing. So some places more coke is there and that starts burning again. Okay. Now, if that comes on the conveyor belt will catch fire, and it's an immense danger. So you can imagine this. There is a set of conveyor after conveyor after conveyor. They are all connected. So if one conveyor catches fire, it's very fast. It will propagate to the other conveyors also. So this was built on the spot. So the thing that I want to tell here is that if we have to make an Industry 5.0 mass consumerized product, it's very important to understand the local inhibitions that are there to be able to build a product. A cookie cutter product, let's say if we had got somewhere from Fleet and all, right? A cookie cutter product does not work for a long time in a place where the product was built without even imagining the place. Now, if you look at the high-end cameras that are getting built, most of the very clean manufacturing centers, or they hardly imagine the amount of dust, the amount of heat that is there, the amount of lack of control over the environment that we have, right? So when we build a device, the device has to be has to know the environment in which it is going to be made. So we did go through a few rounds in building this entire device. We looked at what best we could do at the cost that we can manage economically also. So so we put silicone inside, and silicone is actually a very good cooling medium. So it actually helps in cooling down the internals. It also, we use Loctite, so it also helped us seal. It is a dust catcher. Even if dust enters, it will catch the dust ahead of the electronics, right? So that was also, and another property silicon had was vibration and anti-vibration. So it will protect the instrumentation from, getting damaged due to vibration. The inside we had to prevent, because there's so much of dust, you can actually see, a huge amount of dust actually. So to prevent the ingress of the dust, we actually ensured that the inside of the box is pressurized so that the dust does not enter. Okay. So these are some of the things. And the other thing is that the data needed to be available all across the plant. So we connected to the LAN. Now, we cannot send this continuous imaging data over LAN. It will completely flood the plant LAN system. So the entire server was put here. So we have a NVIDIA server that is working here and receiving. And what the plant sees, only the portal, the web server is running on the NVIDIA. Okay. So this is what, as a part of Industry 5.0, we did it. Let's look at this one. This one was unmanned train detection and alert system. So the trains in, Matix, this is Matix, which is a fertilizer company in Panagarh. So the trains come ad hoc. It is not really known when this goods train will come. And there is a lot of, laborers who are working in the, on the station and on the lines with the urea packaging, right? Urea bags and stacking the bags up and all those things. So we actually designed, and the mechanism that they had was, manual. Someone was announcing, seeing the train somewhere at the gate, level crossing gate, they were announcing, and not the whole platform of 750 meter was alerted of it, right? So we designed a system, but we designed it there. Sitting there on the platform, we understood how to really see a train, goods train, okay, and not a JCB and not a bike, right? And how to work against the winds. So this you are seeing, this was later actually replaced, not replaced, was enclosed in SS316 because there was too much of wind here, right? And there is too much of rain also. It was covered with aluminum. So all this design, along with the entire software, camera, radar, everything, the entire software was getting built and this fabrication was happening, all were happening together. You cannot do this in a assembly line product making, because it will become very difficult to build it there, and then you come here and see that you cannot deploy it considering the environment that is prevailing. Okay, so this is the box I was telling, that it was put in the box, and this is the alert that is there on the platform. There is a buzzer and there is a lighting alert, and all across the platform we have replicated that through relay systems. Okay, so this is an example of being able to design considering the environment, considering the whatever is actually required on the spot. This is also an interesting case study where we did for the society here, and this was making the entire SOS system where SMS could be sent from this device directly, not through a phone. Okay, there is no, in the rural areas where this was built for addressing the domestic violence problem of women, right? So that they could alert the central, police agency or vigilance agency or any group, any helping group from the NGOs, they get alerted that they are going through some kind of torture or violence, right? So this was designed on the bangle. At this point, we are going for further miniaturization of the bangle. The challenge here was that how to send that huge current of 2 ampere that is needed to send SMS directly from this to the, so that was a big challenge, and we had to look at very fundamental principles of I square R losses, which could not be sustained by the flexible PCB, and we had to use very simple mechanism, that is jumper wires, right? So again, innovation on the ground. This is for the greenhouse gas monitoring, where we looked at use of solar and battery together to be able to monitor the soil productivity. One part, soil moisture, soil pH, and all those. Plus the greenhouse gas. So paddy fields are very famous for releasing methane gas to the atmosphere. And there are global rules, global norms now on methane gas control. But we have told that we will not be able to control at this point, but we'll start the measurement. So the measurement nationally has kind of started, and this is where we did it in a paddy field in Bihar, this project. It's close to Patna, and so this was done so that, we are able to monitor the amount of methane that is getting released to the atmosphere. Other parameters were also there. Again, this is another area where we were looking at using the microscopic imaging capabilities, because today what is happening, the sinter, so sinter is a kind of it's pivotal to the one is quality of the steel that is produced, right? That is leading to kind of sustainability. At the same time, all the iron and steel industries are going through huge regulation on the carbon emission, right? Carbon dioxide emission, carbon monoxide also they emit, but carbon dioxide emission mostly causing the global warming, because it's almost, for producing 1 ton, almost 2 to 2.5 tons of coke is required. So that it's so carbon intensive in an industry, right? So being able to control that in situ on the conveyor itself is very important, and that is where we are working today, to be able to predict the sinter quality there itself, so that the controls can happen upstream and not after the lab results have come. Lab results come, by that time the shift is over, you have no control. Okay. The other thing was this dolomite and limestone. So limestone is typically imported from Thailand. It's very costly. Sometimes because they both look similar, sometimes what happens is that they get mixed up, right, on the conveyor. When dolomite should not go, dolomite goes, or when limestone should not go, limestone goes. So that had to be checked on the conveyor itself. So this is another solution that we did the research prototype. Now we have to look at going live with it. This is a very important data collection platform. This is a programmable data collection platform. It's a gateway that we have delivered for Durgapur Steel Plant, and it supports all the different protocols. So data from any part of the plant today can be collected and can be shared to the on the cloud or on their existing enterprise systems for further analysis and further control for sustainability. This is very, very important, or very, very critical for data collection. These are some of the things that we have been asked to work on. We are still, in a research phase on this. The driver performance management, how to understand, and also the car performance management. This is one, and then I will quickly go over to this. This is the robotics is also, so this for this particular thing in very hazardous areas like in urea manufacturing or even in the iron ore steel plant, things when we need to sample, we need to take things and we need to kind of analyze. How far can we do that by the use of robots, and can we do that fast with the use of detection mechanisms then and there itself, right? That's what. So another use was for bag sorting. So this is where these are the projects that we are working on today. It's still in a very conceptual stage, but we just wanted to share. There are other projects also which are in the digital twinning area that we are working today. Finally, coming to this slide, this is how do we sustain the journey from imagination to implementation, and how do we grow our futures, how do we grow our future students, right, to be able to take them over this journey, right? So this is what we have kind of understood, and what we do is that we allow the interns and the students, we allow them to soak themselves into the industry. They go through understanding how the industry is actually working, either through it is through site visits, it is through also going through a lot of YouTube videos, and we ensure that they can start imagining by positioning, immersing themselves and imagining, right? This is very, very crucial for doing any kind of industrial IoT design, because what we are going to do today will be implemented tomorrow without us being able to test until it really goes live. So imagination is a very important part of it. People should start thinking in terms of systems when they look at these things. This is called micro observation training, going down to the very detail. And jobs to be done is a very good framework, because you go on asking, recursive questions until you go to the leaf level to understand the whole thing, right? Then convert this to a scientific platform, to something, numbers that can be measured, right? We have to convert whatever we are seeing and whatever we are imagining into numbers, right? That's important. And then look at the lean startup kind of approach, where we are looking at minimal tech stack for it, okay, to solve the problem. And then a lot of times we do very simple prototypes, mental prototypes, we do paper prototypes, we do small prototypes, and kind of go through the exception scenarios. Now, exception planning, right? Out of 10 use cases, you should think as one use case is a happy path and 9 use cases are exception. So exception design is very important. That is what sets apart the research prototype. Okay. And sets apart the that is what that sets apart go live in production versus any kind of lab prototype. It's very important to do that kind of exception scenario planning and solving. And of course, context filters are what? Context filters are how will this be used? Now, look at the user journeys. Look at it from the operator's point of view. And imagine the operator using the new system, how he's going to feel, how he's going to use it. Is it mounted in a proper comfortable? Is he getting all the data he wants to take his decision? All those things. Think about from the economics of the solution. Is it sustainable? Can we get all the resources that we want? And finally, look at how much of energy is it consuming? How much of carbon footprint is there? So these are the context filters. So this is how we can design the future-proof systems, which we are calling Industry 5.0. This is my details, demographics. We are set up in Durgapur, which is our lab. We have an office here in Kolkata, but that is just business operations, just to keep this running from the all the logistics point of view. But the actual manufacturing or assembly, testing, everything happens either in this module 4 Polashtia industrial area Durgapur, or it is happening at the plant. You will see us in the DSP and Matix sitting there, parking ourselves anywhere and doing the thing. Okay, that brings me to the end. I hope I have been able to cover the sessions. We can, if we have time, we can go for a question answer session. I need to stop share.
Thank you, madam, for your nice presentation. Now, participant, any question you can put in chat box or directly unmute and ask any question of you.
Ms. Chatterjee, thank you very much for kindly accepting our invitation and sparing your time with us, with the participants. and so it is very much on time. Our sessions with Ms. Chatterjee's session, all the lecture session ends. Now I believe we have the test and feedback session. Thank you very much, Ms. Chatterjee.
Thank you. There was one small question, what are the transition phases in terms of, there is no cookie cutter transition phase like this. Actually, Industry 5.0 should be embedded in any Industry 4.0 design. That is the right way to do. You cannot bolt on Industry 5.0 to 4.0.
Yeah.
Okay.
Okay.
Okay, so thank you. I can leave the session now, right? Or
Professor Roy, are you there?
Yes, sir. I'm
Ah.
here.
Mhm.
Already told, already session,
Okay.
it has completed.
Okay. Thank you. Thank
Okay.
you.
Thank
Thank
you.
you, Ms.
Thank you.
Chatterjee, once again. Thank you.
thank you very much. Thank you.
Okay. Then
Mm.
the feedback is shared in the chat box. Please fill it and join the next session, which is on the link test and feedback.
Sir,
you.
only it is in the audio mode only.
Wait for some time because we didn't end this
Okay.
season.
Acha,
Okay,
is this the link, or we have to join through another link or something?
Yes, sir.
Professor
Yes,
Roy?
sir. Yes, sir. I am already shared in the group, sir.
Are Nana, this same link will continue for this thing, or it will be a new
No, sir,
link?
No, there is a new link, sir. It is
Okay,
already
okay.
shared.
Fine. Okay, fine.
Okay, thank you. Thank you, everyone.